Hi everyone, this is coming to you from Education for All. We are looking at differentiating a problem involving exponentials and logarithms here. The question we have on the board reads, the curve C has equation x equals e raised to the y divided by 3 plus 2y. That is the equation of the curve with an exponential function, e raised to the y. Find the coordinates of the point P where the curve cuts the x-axis. And part B says find the equation of the normal to the curve at P. Right. Of course, the first part is quite simple because we are already told to find the coordinates of the point P where the curve cuts the x-axis. So where the curve cuts the x-axis, the y value there is 0. We know that. We are not asked to sketch this curve. In fact, it's a very complicated curve to sketch. We are not asked to sketch it. So let's solve this problem step by step. Let's look at the first part. A. A says find the coordinates of the point P where the curve cuts the x-axis. So where the curve cuts the x-axis at P, y is 0. The value of y is 0. You know that. So if you have this curve, the equation of the curve as x equals e raised to the y divided by 3 plus 2y, where the curve cut the x-axis, y is 0. Y there is 0. Curve cuts x-axis. Y is 0. In fact, it should be like this. Put a comma here. So for now, substitute y equals to 0 in this equation, you will have x equals e raised to the power of 0 divided by 3 plus 2 times 0. So this gives you e raised to the power of 0 is 1. 3 plus 2 times 0 is 0. So you get 1/3. So therefore, question 1 is already answered. The curve, the coordinates of the point P where the curve cut the x-axis, the coordinates there is x, which is 1/3, and y is 0. Those are the two, this is the coordinates, these are the two values. At x equals 1/3, the curve cuts the x-axis. So number 1 is solved. Now let's go to number 2, or B, the B part, which is the most interesting part. And that will end. The B part says, find the equation of the normal to the curve. Whenever you are asked to find the equation of a normal, let's say you have this function and you have a graph like this. Sorry, this graph is not elegant. You have a graph like this. This is your y, this is your x. Right? And then you want to find a point. You want to find a gradient at a particular point on this graph. You draw a straight line like this. So this point here We want to find the tangent of this line at this point. That is the tangent of the graph at this point. So this line is our tangent line. You can be able to find the equation of the tangent of this line because at this point, you already know what x value is and y value is at this point. And with respect to this problem, this is not the graph. This graph looks like it has to be really, I don't want to assume how it looks like, but being that y is 0 and x is 1/3, so it has to cut through this one. I'm just giving you to explain. So if this point here is P, now what they are asking you to find the equation of the normal to the curve. So this tangent line, straight line, sorry, this should be a straight line. To find its normal, you have to find a line that is perpendicular to it. So that line should be something like this. Must be 90 degrees. So this is your normal line. Normal means perpendicular to this horizontal line. You have a line like this. So this is your normal. And this is your, if it's a curve, this is your tangent. Right? So you are looking at finding the equation of this normal that is perpendicular to the tangent line. That's what this problem is saying. So how do you go about that? Now let's see. We all know that to find the gradient of a function, you differentiate that function with respect to x. And those functions, how do they normally look like? You can have y equals x squared all over 3x plus 4, or f of x equals x squared all over 3x plus 4, for example. Then, when you want to differentiate this, you want to find the gradient of this function. You differentiate. For this first one, you can say dy dx. For the next one, you can say f prime of x equals, then you do your differentiation. Yeah? So you have y. Let's stick with the first one. You have y equals something, something. Then it's easy for you to find dy dx. And use your quotient rule. V du minus u dv all over v squared. So you have y equals to this. But when now you have x equals to y all over 3y plus 4, then this is something different. And you want to find the gradients of this function or that curve. You see, here we have y. This is what we are used to having. Y equals to x something. Now here we have x. And you want to differentiate with respect to x. It becomes difficult. But there is a way to go over it. This is where implicit functions come in. If you ever heard of this, implicit function, that is what we have here. We are not having y equals to something. We are having here x, and we want to differentiate with respect to x, because finding the gradient means differentiating with respect to x. So what do we do? What do we do in this case? What we do here, we cross multiply, so we'll have x times 3 plus 2y equals e raised to the y. So now we differentiate. So we are going to differentiate the the x 3 plus 2y equals d dx e raised to the y, because you are differentiating with respect to x, not with respect to y. So this is now an implicit function. So we are going to differentiate it using the rules of implicit function. This is a product, x times 3 plus 2y. This is a product. So when you want to differentiate something like this, you know the product rule. The product rule is u dv plus v du. We've covered that. So differentiating this one gives you this. If we say this is uv, so v, which is 3, if you have uv and you want to differentiate this one, if y equals uv, let me just show what I'm doing. If y equals uv, then dy the x equals v du plus u dv. This is what I'm doing here. So this is u, this is our v. So v du, so therefore 3 plus 2y times, now differentiates x with respect to x. So you get 1. Second case, now we have, this was v du, now u, which is x, dv. We are now differentiating dv, d dx 3 plus 2y. This is what we are doing here. And again, we are differentiating because this is an implicit function. So what do we do here? Again, we are differentiating this. When you differentiate this exponent, this e raised to the y, natural logarithm, you always get natural logarithm. So you will get e to the y, dy, dx. So for here, you are differentiating with respect to the x. There is no dx, but these three don't have anything to do. It's a constant. So what is left here is just 2y. It's just 2y dy. Yeah? So you have 3 plus 2y times 1 is this, plus x times 2y dy dx equals e raised to the y dy dx. It's a long video. So this is what you get. Now let's collect like terms and simplify. Once that is done, then the problem is solved. So 3 plus 2y, this is x times 2y. So this and this, we can bring them together because this has dy dx, this one also dy dx. So we can bring these two together. So there you will have 3 plus 2y now is equals to e raised to the y, dy dx. This will now become minus x times 2y dy dx. Right? So here we can take dy dx out. So you will have dy dx e raised to the y minus 2y x. That is what you get. If you take the y dx, it's 2x minus 2x gets minus 2x. No, here. You get in? No, you only have, oh, sorry. You're only having here, um, no. The mistake here. Yeah. This is where it goes wrong. When you differentiate this, you get dy dx. You are differentiating only y here. So you have your x here. That's why. So you have only 2x here. There is no y. 2x. Just like what we did here. We differentiated x, so it goes to 1. Here we can't differentiate y because we're differentiating with respect to x. So this y is this dy dx. This y is this dy dx. And this 2 is still here. And the x is there. So the y goes. So this is what you get. Anyway. So now, and this is all equals to 3 plus 2y. But you want dy dx, not like this. So this gives you 3 plus 2y divided by e raised to the y minus 2x equals dy dx. So this is the gradients. But we need a value for the gradients. We need a value. We know y is 0 and x is 1/3. So putting those values here, you will now have 3 plus 2 times 0, because y is 0, divided by e raised to the 0, y is 0, minus 2 times 1/3. Because this is now the gradient. This one is the gradient. So this gives you 3 divided by e raised to the 0 is 1 minus 2 all over 3. So 3 minus 2 is 1. 3 minus 2 is 1, 3. So this boils down to 9. So the gradient of the tangent to the curve at point P is 9. Now we got it to be 9. And that is for the tangent. What about the normal? Well, we know there is, I need space, a relationship between the gradient of the normal and the gradient of the tangent to a curve. Their relationship is the gradient of the normal, which is, let me say, the gradient of the normal, which is nm, times the gradient of the tangent, which is mt, to a curve. Their relationship is -1. Their product is equals to -1. So now we have the gradient of the tangent to the curve is 9 minus 1. So for the normal, gradient, gradient is m. We represent it by m. So the normal is -1 all over 9. So now what we're asked to find the equation of the normal to the curve. We know the gradients now. We need the equation. So the equation now will have y minus y1 all over x minus x1 equals to the gradients. Because this is rise all over run gives us the gradients of a curve. Yeah? So we know what y1 is. Now you have y minus y1. y1 is 0 divided by x minus x1 is 1/3. And their product, we have mn, which is, the mn we know is -1 all over 9. So this gives us y all over y equals -1 all over 9 multiplied by x minus 1/3. So this is y equals to -1 all over 9x minus This gives us plus 1 all over 27. So this is our final answer. This is our final answer. Thank you for watching. Bye-bye.